Hello, and welcome to the graphs of the sine and cosine functions. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas El Paso and an assistant professor at Doña Ana Community College. This is for Math 1508 Pre-Calculus at UTEP. Chapter 4 Trigonometry comes to us from Larson's 10th edition calculus text. Section 4.5 Graphs of the sine and cosine functions. Alright, so graphing trig functions in general. In order to graph any of the trig functions, you need to know the 5 key points or 5 key values for one period. And for sine and cosine, that's 0 to 2 pi. We'll find different periods for 2 of our other trig functions, but for now, let's just keep things between 0 and 2 pi and know what's going on. So we could use these points on the graph of our unit circle to unravel the unit circle into a linear graph. So remember, for any angle, the sine is the y value. So I take my y values, the y values from the unit circle. 0 radians corresponds to a y value of 0. Pi over 2 radians, y value 1. Pi radians 0, a 3 pi over 2 is a negative 1. And I come back to 2 pi and have a y value of 0 again. So I put that into a linear graph. My input being my angle, right, sine of theta. My output being the y coordinate of my 5 key x value. So, 5 key y value. The y coordinate of the points of the unit circle. Man, that just got confusing in my head. So I have 0, 0, pi over 2, 1, pi 0, 3 pi over 2 negative 1, and 2 pi comma 0. Notice the sign kind of makes a lazy S. Alright, so it might be backwards, whatever. It's kind of a lazy S motion. Starts at 0, hits 0 2 more times at multiples of pi. If we go to analyzemath.com, and I steal graphs from them all the time for my lectures, and so I want to give a shout out, let you know I didn't do this. You can see that their much prettier graph looks the same. It has the same motion to it, the same scaling, and so on. Remember, cosine consists of the x values of the points along the unit circle. So, 0 radians, my output is 1. Pi over 2 radians, my point has an x value of 0. At pi, x value is 1. At 3 pi over 2, we have a 0, and going back to 2 pi, my output is 1. So, even though I'm talking about x point of this point on the unit circle, for an input of 0 radians, my output is 1. Cosine of 0 equals 1. Cosine of pi over 2 is 0. Once I'm reporting these values, they're no longer x's and y's. This is just the output of the cosine. So it turns into an input angle. Output happens to be from these points. What's going on here? 0, 1. Pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi comma 1. Notice how it's kind of a weird looking C. All right, the cosine has this C looking shape to it. If these were bent in, it'd look better, but whatever. 0, 1, same basic shape that I have up here. So an S, a sine curve, has a smooth S shape. It has two, a high and a low. Whereas a cosine graph looks like a C. There's only one curve to it. So, some definitions. The amplitude of y equals a sine of x and y equals a cosine of x represents the half the distance between the maximum and minimum values of the function and is given by the amplitude equals the absolute value of a. Alright, so we just want the positive. Since it's a distance, I don't care if it's positive or negative, I just want the number part, the no sign. If b is a positive number, the period of y equals a sine of bx and y equals a cosine of bx is given by period equals 2 pi over b. Notice that for algebra, I called multiplication in front of a function, that was a vertical stretch or a shrink. And now we call that amplitude, but it's the exact same thing. In here, we're multiplying directly with the x. In algebra, we called that a horizontal stretch or a shrink. And what we're going to call it here in trigonometry is a shrinking or stretching of the period. Normal period of sine and cosine are 2 pi. And since multiplication on the inside, right, multiplication by x has the opposite effect on the outside, that's 2 pi divided by b in order to find the period. So if we're given y equals a negative 4 sine of x, my a is negative 4. My b, what's being multiplied by x? 1. My amplitude, therefore, is the absolute value of negative 4, which is 4. My period is 2 pi over 1, or 2 pi. That's it. Y equals a negative cosine of 2x over 3. My a value is negative 1. My b value, right, this is 2/3 of x. My amplitude is the absolute value of negative 1, which is 1. The period is 2 pi divided by 2/3. That's 2 pi times 3/2, which equals 3 pi. Let's make sure you get what I'm saying here. If I take a look at the graph of the sine function, standard sine function, the distance from the top to the bottom, and half of that distance happens to be at this halfway mark. So this is the amplitude. The amplitude is half the distance from the high point to the low point. So half the distance from the top, from the maximum to the minimum will be 4 for this graph, whereas the distance, half the distance will be 1 for our second graph. If y equals 1/5 sine of 6x, 1/5 is my a value, therefore my amplitude is the absolute value of 1/5 is 1/5. My b value, what's being multiplied by x, that's 6. So my period is 2 pi over 6, which simplifies to pi over 3. Amplitude 1/4. Period, 2 pi divided by 2 pi, so a period of 1, and that always trips me out. It's easier, yet it's harder, because we're used to thinking in terms of radians after a while, and when there's no pi left, but it's still a measure of radians, get used to it. It won't happen all the time, but it'll happen frequently. So, more on the graphs of sine and cosine. Now, I'm going to multiply x by b, and I'm going to subtract a constant c on the inside, and I'm going to add a constant d on the outside of the function. So we're still back in shifting our functions. Shifting polynomials or shifting basic functions is what we talked about in chapter 1 of our pre-calculus text. Same thing, just different names. We'll do the same thing for cosine. Amplitude, we already saw, is absolute value of a. The period is 2 pi over b. The left endpoint of a one-cycle interval can be determined by solving the bx minus c, the inside of the trig function. Cosine of what? Cosine of bx minus c, set it equal to 0. Because we know that 0 is the first of the 5 key x values. So the left endpoint, set bx minus c equal to 0, and there we go. We also call this the phase shift. Phase shift, but I think that's on the next slide. The right endpoint of a one-cycle interval can be found by setting the inside, bx minus c, equal to 2 pi. All right, so left endpoint starts at 0, right endpoint ends at 2 pi. You can also find the second, third, and fourth intervals by setting bx minus c equal to pi over 2, pi, and 3 pi over 2 respectively. The number c over b, when I set bx minus c equal to 0, I'll add c divided by b. So the number c over b is the phase shift, horizontal translation. Whereas this number d is the amount of the vertical translation. And this represents the new center line of the graph, because it'll be from d that we go up and down based on our amplitude. So if I want to sketch the graph of y equals 4 sine of x, I know my amplitude is 4, my period is 2 pi over 1. There's no vertical shift, there's no horizontal shift. The height's the only thing that changes in the graph. So I label my 5 key x values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. These are the quadrantal angles from the unit circle. Only difference is now I label this height 4 and this depth at negative 4. I could easily change that to an 8. The only thing I would change is make that an 8, make that a negative 8. Otherwise, it still looks like the graph of sine. Haven't shifted left or right, haven't shifted up or down. There we go. Whereas, if I have y equals sine of 4x, and the 4 is now on the inside rather than the outside, the amplitude is 1, and the period is 2 pi over 4, which simplifies to be pi over 2. It's still the graph of sine, but this time, because my 4 is messing with the x, I changed the scaling on my x-axis. So what I did is I set 4x equal to 0 to get x equals 0 for my first point. I set 4x equal to pi over 2 to get my second value, and so on in my right endpoint. 4x equals 2 pi. Yeah, it's a crazy way to write pi. It looked a lot like an x. That's how I get my right endpoint. So I can find the scaling on the x-axis, but it's still going to look like the sine function. The only thing that changed here is how I labeled my x values. If I'm given y equals -10 cosine of pi x over 6, the amplitude is the absolute value of -10, which is 10. The period is 2 pi divided by pi over 6. That's 2 pi times 6 over pi, which is a total of 12. Now this negative on the outside says the graph has a vertical reflection. So cosine usually starts high. Because it's a reflection, it's going to start low. And it's still going to look like a cosine. It's just flipped over. These come from circles, right? I'm tearing apart a circle. And so it should be round and not jagged. There's 12, right? The period is 12. So I start at 0, because there's no add or subtract, no horizontal shift, nothing on the outside, no vertical shift. 0 to 12, half of that is 6. Half of 0 to 6 is 3, half of 6 to 12 is 9, and I have my 5 key x values, 0, 3, 6, 9, and 12. Alright, here's what Bugs Bunny would call the coup de grace. Y equals 4, so our amplitude is 4. Cosine of x plus pi over 4. Period is 2 pi over 1. The left end point is when x plus pi over 4 equals 0, so x equals negative pi over 4. That's my phase shift, so that's where I'm going to start. And then the plus 2 tells me my graph is shifted up 2 units, so my center line is up 2 units. Normal center line of cosine is 0. I shift it up 2 units, my y equals 2. This is not part of the graph, it's just part of how I can describe what's going on in the graph. So if this is a height of 2, I know cosine starts up, so at negative pi over 4, I'm going to go up 4 from my center line and get a height of 6. Add pi over 2 to get the next value, because I haven't changed my period at all, so the distance of pi over 2 between them all. My second key x value is center line. My third key x value is minimum, so 2 minus the amplitude of 4, which would give me negative 2. My fourth value is center line, and my fifth value is high, so from center line add 4 and I get to 6. All the values are up or down 4 units from the midline of y equals 2, unless they're the two that are on the midline. 4 times the cosine of x plus pi over 4 plus 2. If I want to get my other values, we know the left and right endpoints. If you want to solve for the 3 in the middle and you don't like the idea of let me just add pi over 2, you can always just solve the little equations, the inside. What's inside the trig function? X plus pi over 4. What are the standard values of the unit circle? We already did left endpoint of 0. We did right endpoint that was equal to, 2 pi. So the 3 in the middle equal to pi over 2 pi and 3 pi over 2. So if you don't like the half and half method I talked about in the last slide, you can just solve a bunch of mini equations and it's going to be the same thing. Just get ready to deal with fractions. Alright, so what's going on with this function? G of x equals sine of 2x plus pi. I know multiplying on the inside is going to be a horizontal shrink by a factor of 2, so what it does is it makes my period half as long. Instead of 2 pi, now it's pi. I know that the horizontal shift is when I add or subtract on the inside. It's 2x plus pi. So 2x plus pi equals 0. Subtract pi, divide by 2. I go left, pi over 2. That's my phase shift. Horizontal shift, if we're talking about algebraic functions, we call it phase shift for trigonometric functions. But it's the same process. If we have 1 plus cosine of x plus pi, the 1 tells us it's vertical shift up 1 unit of the midline. The cosine of x plus pi, that's a horizontal shift. Horizontal shift x plus pi equals 0 becomes x equals negative pi, so I went left pi units. So I'm going to start my graph at negative pi. Midline is 1, amplitude is 1, so I start up, come down, just a little new midline, shifted left. G of x equals 4 minus sine of 3x minus pi. I have a vertical shift up 4 of my midline. The negative says I'm reflected across the y-axis, so the graph of sine normally starts up and comes down. This reflection tells me it starts down and then goes up. 3x multiplying by 3 is a horizontal shrink by 3, so my period is 2 pi over 3. 3x minus pi, my horizontal shift. 3x minus pi, add pi, divide by 3, and I get to the right by pi over 3 units. Alright, so let's talk about something real. When tuning a piano, a technician strikes a tuning fork for the A above middle C and sets up a wave motion that can be approximated by this function. Y equals 0.001 sine of 880 pi t, where t is the time in seconds. I know you musicians out there, I'm ruining it, right, with math. You know way more math than you ever want to admit. What we're going to do is we're going to find the period of the function. Well, the period, right, just comes from whatever is multiplying by my variable. The frequency f is given by frequency is 1 over period. So I want to know what the frequency of the note, the A above middle C is. Well, the period is 2 pi divided by 880 pi, so that's 1 over 440. The frequency of f is given by f equals 1 over p. So what's the reciprocal of 1 over 440? Well, that's 440. And that's why frequently you'll hear A440 is what we're going to tune to. Or they tuned to A440, and that is the A above middle C is a frequency of 440 hertz. Alright, let's talk about a Ferris wheel. And we'll see this Ferris wheel example throughout several of the applications that we do. It's because it's a nice one. It's a nice circle that hopefully everyone knows about. If not, here we go. A Ferris wheel is built such that the height h in feet above the ground of a seat on the wheel at time t seconds can be modeled by our function h of t equals 53 plus 50 sine of pi over 10 t minus pi over 2. We're going to find the period of the model. That's going to use our pi over 10. But what does that actually tell us? Then we're going to find the amplitude of the model. Hint, it's 50. But what does that actually tell us? So first, the period is going to be 2 pi divided by the coefficient of our variable. So 2 pi over 10. That's 2 pi times 10 over pi. Pi's cancel. That's 20. The period, literally, it's the period of time it takes to make one complete revolution. It takes 20 seconds for this ride to go around one time. The period. The amplitude. The amplitude is 50, right? It's the absolute value of the coefficient of the sine or cosine. So the amplitude is 50 feet. The center line of the Ferris wheel is 53 feet. Think of the center of all the spokes on the Ferris wheel. That's 53 feet. If the amplitude is 50, that means that the maximum height is 53 plus 50 feet above ground, and the minimum height is 53, the midline, minus 50, so 3 feet off the ground. It's really important that the minimum is off the ground unless you're building a trench for your Ferris wheel. And if you ever see a Ferris wheel that has a trench built in it because they put it up wrong, would you please send me a picture? Tuesday Johnson at UTEP. That's not the email, but Google those three things. Tuesday Johnson, UTEP. You'll find my email. Send it to me. I would love to see that picture. That's it for me. Thanks for listening to Graphs of Sine and Cosine.